To understand silver ticket attacks, it's helpful to first see how Kerberos authentication normally works. In standard Kerberos authentication, a user requests a ticket granting ticket from the authentication server in step 1 and step 2, then uses that TGT in steps 3 and 4 to request a service ticket from the ticket granting server, which finally allows access to the target service in steps 5 and 6. This process ensures that all authentication is validated by the Key Distribution Center KDC. A silver ticket attack involves forging Kerberos service tickets using a compromised service account password hash. This allows attackers to access specific applications, databases, or network services directly without interacting with the key distribution center. Think of silver ticket attack as creating a counterfeit key to a specific room rather than a master key to the entire building. When attackers obtain a service account's password hash, they can forge service tickets that provide direct access to that service without going through the normal Kerberos authentication. These forged tickets appear completely legitimate to the target service, enabling persistent, stealthy access. The term silver reflects both the value and precision of these attacks. Attackers prioritize services containing sensitive data, SQL databases with customer information, file servers with intellectual property, or exchange servers with confidential communications. Silver tickets provide persistent access that survives user account changes and standard security rotations. But this persistence only lasts until the specific service account password is changed, highlighting why regular password rotation is so critical for service accounts. Most importantly, these attacks operate below the radar of standard Kerberos monitoring, which we will examine in detail when we discuss detection challenges. Now let's examine how attackers position themselves to execute these attacks. Silver ticket attacks require fewer privileges than golden ticket attacks, making them more accessible to attackers. The primary requirement is obtaining the password hash of a target service account, which can be accomplished through various methods without necessarily achieving domain administrator access. This lower barrier to entry makes the silver ticket attacks a common post exploitation technique for maintaining persistence in compromised environments. Hackers typically obtain service account hashes through several methods. Kerberos attacks specifically target service accounts by requesting service tickets and then attempting to crack the encrypted portions offline. Local credential extraction involves compromising servers where service accounts are running and extracting stored credentials from memory or local storage. Attackers prioritize certain types of services for silver ticket attacks based on the value of data they protect. SQL Server databases often contain sensitive business data and customer information. Web application service accounts may provide access to user data and business logic. File share services can expose confidential documents and intellectual property. Exchange server services grant access to email communication and calendar information. Custom enterprise applications often contain proprietary business processes and sensitive operational data. Now let's see how silver ticket attacks work. The first step, service account reconnaissance, involves identifying valuable service accounts and their associated service principal names. Service principal names uniquely identify service instances in Kerberos realm and are essential for proper ticket creation. Attackers use tools like PowerView or Bloodhound to enumerate service accounts and their associated service principal names. They also need to determine the target service's location and configuration to ensure the forged tickets will be accepted. The second step, service ticket forgery, is where attackers create the malicious tickets. The ticket creation process for silver tickets is more focused than golden tickets, but equally powerful for specific services. Hackers create service tickets that grant access to the target service, often setting validity periods that match normal service tickets' lifetimes to avoid detection. Unlike golden tickets, which can include any group memberships, silver tickets are limited to what the target service recognizes and enforces. The forged ticket is signed using the compromised service account's password hash, making it appear legitimate to the target service. Unlike standard Kerberos authentication, silver ticket attack bypasses the KDC entirely after the attacker has obtained the service account hash. Instead of following the normal flow, where a service ticket is requested from the ticket granting server in step 3 and issued in step 4, the attacker forges a valid service ticket and presents it directly to the target service in step 5, skipping the KDC interaction altogether. Attackers can access service specific resources, execute authorized operations, and potentially use the compromised service as a pivot point for lateral movement within the network. This table highlights how a silver ticket attack subverts the normal Kerberos authentication process. Notice that unlike standard authentication, the attacker skips the steps involving the key distribution center and interacts directly with the target service. This bypass is what makes silver ticket attacks hard to detect. While golden ticket attacks compromise the and interact with the KDC throughout the authentication flow, silver ticket attacks focus solely on the service ticket and interact only with the target service as illustrated in our authentication diagram. Golden tickets manipulate steps 1 through 4 of the normal flow, while silver tickets forge service tickets and only interact at step 5. This distinction is critical for understanding detection and defense strategies, which we will examine next. I hope this overview helps you understand how silver ticket attacks work and why defending against them is so critical for enterprise security. Thank you for watching, and I'll see you in the next cybersecurity video.